Hello viewers, it's good to come your way again in another session as far as this tutorials is concerned. Alright, in this particular session I'll be discussing trigonometry, and it's going to be very broad and very elaborate. On the screen you can see the objective of this session, which is to establish what trigonometry is all about, discuss trigonometric ratios, discuss trigonometric identities, of course establish what we mean by complementary angles, discuss ratios of special angles, talking about 0 degrees, 30 degrees, 45 degrees, 60 degrees, and of course 90 degrees. These angles are considered special as far as mathematics is concerned. Also, I will establish the sum and difference of angles, the formulas we have for sine A plus B, cos A plus B, tan A plus B, and also for the difference sine A minus B, cos A minus B, and of course tan A minus B. Also, as far as trigonometry is concerned, I'll discuss quadrants, which is dividing a circle into 4, first, second, third, and fourth quadrants. We'll look at the ratios of these angles in each quadrant, and of course finally I'll wrap it up with trigonometric equations. As you can see, it's going to be a very long and intensive session as far as trigonometry is concerned, so don't go anywhere. Fasten your seat belt, get a comfortable seat, and let us roll it out together. Alright, so for this particular one, I'll be discussing trigonometry. I will establish ratios of special angles, and of course we'll use that to solve some mathematical problems as far as this particular session is concerned. Alright, on the screen you can see that trigonometry is the study of triangles with respect to their sides and of course their angles. Trigonometry is the study of triangles, and we have different types of triangles. Of course we have different types of angles too. Now when you say triangle, it's a figure with 3 angles. Of course, you know an angle is just a meeting point of 2 lines. Whenever 2 lines meet, you always have an angle formed at that point. So trigonometry is going to discuss what triangles are all about, and of course how we can use them in solving a lot of mathematical problems. So trigonometry is the study of triangles with respect to their sides and of course their angles. Triangle, 3 angles, 3 sides. Now angles of course are classified as acute. Don't forget, angle is a point, is a meeting point of 2 lines. Alright, and these angles are classified as acute, as right angle, as obtuse, and of course as reflex. Any angle that is less than 90 degrees in mathematics is called an acute angle, like 30 degrees, like 60 degrees, like 45 degrees. These angles are less than the value 90 degrees, and of course they are referred to as acute angles. Now for the right angle, any angle that is equal to 90 degrees itself is called a right angle. Alright, so if I have 2 lines meeting and the 2 lines are perpendicular to each other, alright, an angle will be formed as 90 degrees. That angle is called a right angle. And of course we have the obtuse angle, which is an angle where the value is more than 90 degrees but is less than 180 degrees. Value less than 90 degrees is called an acute angle. Value equals to 90 degrees is called a right angle. Value more than 90 degrees but less than 180 is called an obtuse angle. And finally, if it is more than 180 but is less than 360, such an angle is called the reflex angle. Alright, now since trigonometry is the study of triangles with respect to their sides and angles, we also have the different types of triangles which we'll be discussing as far as this session is concerned. Alright, so angles are classified as equilateral triangle. Equilateral, equi means equal, lateral means lines. So equilateral triangle is a triangle where the lines, which is the sides, are equal. And of course if the sides are equal, it also corresponds to the fact that the angles are also equal. So that's the first type of triangle we have, the equilateral triangle, equal sides and equal angles. The isosceles triangle has 2 sides to be equal, and of course if 2 sides are equal, the 2 angles supporting those 2 sides are also equal. These of course are called the base angles. Alright, and of course the right angled triangle is a triangle where one of the angles is 90 degrees, and of course the scalene triangle finally is a triangle where none of the sides is equal. All the 3 sides are different from each other, meaning all the 3 angles too will be very different from each other. Right, so that's what trigonometry is all about. On the next slide, of course, we have the trigonometric ratios. We have three basic trigonometric ratios, as you can see on your screen, as sine, as cosine, as tangent, and of course we have the other ones that are inverses of the basic trigonometric ratios, as cosecant, as secant, and of course as cotangent. Now this is what we mean. In a right angle triangle, of course I have mentioned this before, one of the triangles we have is called a right angle triangle, where this particular side is 90 degrees. Alright, let's say I have an angle here that is called theta. So this side, okay, I can label my triangle as capital A, my capital B, and capital C. So my three angles here, I told you earlier that trigonometry is the study of triangles with respect to their sides and angles. So my three angles here are capital A, B, and C. Now the side opposite each of the angle is the small letter. Okay, so here I have small a opposite angle A, small b opposite angle B, and of course small c opposite angle C. Now with respect to this angle called theta, this side C is our opposite side. So this side C is called the opposite side, is opposite to the angle C. This guy that is opposite the right angle is always the longest side, which is the hypotenuse side. So this guy is called the hypotenuse side. Okay, and of course finally we have this side that is opposite angle A. The remaining side, of course, is called the adjacent side. This is how we label a right angle triangle. Capital A, B, C are the angles, and of course the sides are small a, B, and C. Small a is our adjacent side, small c is the opposite side with respect to the angle theta, and of course small b is our hypotenuse side, which of course is always the longest side. Now we have the basic trigonometric ratio as sine theta, and sine is the ratio of the opposite side to the hypotenuse side. So our sine here is opposite over hypotenuse, which according to what I've drawn, the opposite side of course is C divided by the hypotenuse side is B. Alright, the next trig ratio we have is cosine, which is cos, abbreviated as cos, and is given as the ratio of the adjacent side to the hypotenuse side. So we have adjacent of hypotenuse is the mathematical expression for cosine. Alright, so the adjacent side here is A divided by the hypotenuse side, which of course is B. And finally we have tan theta, which is the ratio of the opposite side to the adjacent side. So we have tan to be equals to opposite over adjacent, and this is equals to the opposite side here is C, and over the adjacent side of course is A. So we have C over A. Now back then in school, there's this mnemonic we use in order to be able to recall at easily the various trigonometric ratios that we have, and that mnemonic is given as sine A stands for opposite over hypotenuse, that is OH. The next one is cosine, which stands for adjacent over hypotenuse, AH, and finally we have T for tan, standing for opposite over adjacent. So we have SOCAHTOA. Now SOCAHTOA will give us the simple definition for the three basic trigonometric ratios as sine, cosine, and tan. Sine A is opposite of hypotenuse, cosine C is adjacent of hypotenuse, and of course tan is opposite over adjacent. So we have this as SOCAHTOA. Those are the three basic trigonometric ratios we have. Now if you take inverse of each of them, you can have another trigonometric ratio, of course, which is given as cosec, sec, and of course tan or cot respectively. Now if sine theta means opposite over hypotenuse, which according to what we wrote earlier, the opposite side was C over the hypotenuse side was B. Now if I take the inverse of sine, so I have 1 over sine theta. This is another trigonometric ratio that is called cosecant, abbreviated as cosec theta. So cosec theta is now inverse of, that's 1 over C over B, opposite side to the hypotenuse side, which will now give us B over C. That means hypotenuse now over opposite. If you take inverse, if you take inverse of a fraction, you always invert the fraction. The numerator becomes the denominator, and of course the denominator becomes the numerator. So if sine theta is opposite of hypotenuse, inverse of that is another trigonometric ratio we call cosect, and that will now give us hypotenuse over opposite. Alright, the second trig ratio we had was cos theta, which was given as adjacent over hypotenuse, and from that diagram I drew earlier, you can see that our adjacent side was A, and of course our hypotenuse side was B. Alright, so that means our cos theta gave us adjacent, which is adjacent side is A over hypotenuse side was given as B. Alright, so if I now take the inverse of cos theta, that will give me another trig ratio that we call secant, abbreviated as sec theta. Alright, so that's the inverse of cos. Okay, so that now means 1 over cos was A over B, so this guy will now be B over A, which means the hypotenuse side over the adjacent side. That's now another trig ratio that is called the sec theta, that's secant, abbreviated as sec theta. And finally, the other trig ratio we had was for tan theta, which of course was opposite over adjacent. That was how we define tan. That was C over A. Now if I take the inverse of tan theta, I have 1 over tan theta. This gives me another trig ratio we call cot theta, that's cot tangent, abbreviated as cot theta. And cot theta now means 1 over tan was C over A. So inverse of this will now give me A over C, which now means the adjacent side all over the opposite side. So that gives us our cot. So in summary, the basic trig ratios we have are sine theta, cos theta, and of course tan theta. Taking their inverses, that's for each of them, you have what is called cosec theta as inverse of sine theta. You have what is called sec theta as inverse of cos theta, and finally you have what is called cot theta as inverse of tan theta. These are the trigonometric ratios we have, 6 of them. The first 3 are the basic trig ratios: sine theta, cos theta, and tan theta. And of course, taking each of their inverses will give you the cosec theta for sine, the sec theta for cos theta, and of course the cot theta for tan theta. Those are the basic trigonometric ratios we have. Now on the screen you can see that the next thing I have to establish is what is called the Pythagoras Theorem. Now there's a very important and useful theorem as far as a right angle triangle is concerned, which of course will always help us to be able to evaluate some mathematical problem that need us to find one of the sides of a right angle triangle, and that theorem is called the Pythagoras Theorem. Now on the screen you can see that the Pythagoras Theorem states that in a right angle triangle, the square of the hypotenuse side is always equal to the sum of the squares of the other 2 sides. The square of the hypotenuse side is always equal to the sum of the squares of the other 2 sides. This is what we mean. From that diagram I drew earlier, I had a right angle triangle as this, and I had labeled this as theta. Now this was our capital A, capital B, and capital C. This side is small c, this side is small b, and of course this side was our small c. Pythagoras theorem says that the square of the hypotenuse side from this triangle, now my hypotenuse side is b, so b square is equal to the sum of the squares of the other 2 sides. The other 2 sides I have small c, that's the opposite side, and small a, the adjacent side. So I'm going to find the sum of their squares. So I'm going to have c square plus s square. Alright, this is what we call Pythagoras theorem. The square of the hypotenuse side, which is distance AC, which of course is b. So distance AC is equal to the sum of the squares of the other 2 sides. C is actually distance AB, so you can write it in this form also, plus A, which is the adjacent side, is distance BC, that's from B to C. Alright, so that is Pythagoras theorem, that the square of the hypotenuse side is always equal to the sum of the squares of the other 2 sides. This is only applicable in a right angled triangle. Alright, so finally for this particular session, we have an example on the screen where we are asked to evaluate the value of cosec theta, sec theta, the angle here is not theta, it's alpha. I'm using alpha, it can always be anything. Alright, we are asked to evaluate the value for cosec alpha, sec alpha, cos alpha minus sine alpha, cot alpha. Of course, you might be wondering what is alpha. It's just something used, it's a Greek alphabet used to represent an angle in this case, just as we can use theta too. Now the question has given us sine alpha as 3/5, and we have to evaluate the following. So we come here and we interpret the equation as this. Our sine alpha is equals to 3 over 5. We draw a simple right angle triangle to represent that. So we have 90 degrees here. We have our angle alpha. Sine is opposite, so the opposite side is 3. For sine theta to be given as 3 over 5, it means 3 is for the opposite side and 5 is for the adjacent side. Since sine is defined as the ratio of the opposite side to the adjacent, the hypotenuse side, opposite to the hypotenuse, the ratio of that. So sine 3 over 5 means that the opposite side is 3 and of course the hypotenuse side is 5. So I fix it up here, and I don't know this adjacent side, I can call it x. So of course we can apply Pythagoras theorem here, that the square of the hypotenuse side is always equal to the sum of the squares of the other two sides. This will enable us find the adjacent side now, which is given as x. Okay, so the hypotenuse side here is 5, so 5 square is equal to 3 square plus x square. The square of the hypotenuse side is equal to the sum of the squares of the other two sides. So 5 square here is equal to 3 square plus x square. 5 square is 25 is equal to 3 square is 9 plus x square. Alright, take 9 to this side. I have 25 minus 9 is equal to x square, meaning that x square is equal to 16. That's 25 minus 9 will give us 16. So x here is equal to square root of 16, giving us x to be equal to 4. Alright, so that means that our adjacent side here is 4. Alright, that is how we can find that adjacent side using the Pythagoras theorem. That in the square of the square in a right angle triangle, the square of the hypotenuse is always equal to the sum of the squares of the other two sides. Now back to our question, we're asked to evaluate cosec alpha, sec alpha, cos alpha minus sine alpha, and of course tan or cot alpha. So the first one is cosec alpha, and of course cosec is the inverse of sine. Alright, so cosec alpha means 1 over sine alpha, which is 1 over sine alpha was 3 over 5 from the equation. So inverse of 3 over 5 means we turn the fraction upside down, numerator becomes denominator and denominator becomes numerator. So inverse of 3 over 5 will now give us 5 divided by 3. Okay, the second point, we were asked to find sec alpha. Sec alpha is actually 1 over cos alpha, which is equal to 1 over cos is actually the ratio of the adjacent side to the hypotenuse side, and our adjacent side here is 4 over the hypotenuse side here is 5. So cos alpha there is 4 over 5, and inverse of that will give us sec alpha. So inverse of this is going to give us 5 divided by 4 if I take the inverse of that fraction. Alright, the third question they were asked to evaluate cos alpha minus sine alpha. Okay, so we have cos alpha minus sine alpha, cos alpha minus sine alpha, which is equal to, cos alpha is the ratio of the adjacent to the hypotenuse. The adjacent from Pythagoras theorem, we got it as 4. So cos alpha now becomes 4 over hypotenuse is 5 minus sine alpha, of course, is 3 over 5 from the original equation. So this is equal to, now since the denominators are the same, we just subtract the numerators. Alright, so 4 minus 3 will give us 1 over 5. That becomes the value for cos alpha minus sine alpha. And finally, we were asked to evaluate cot alpha. Okay, and cot of course is the inverse of tan. So cot alpha means 1 over tan alpha, which is equal to 1 over, tan is the ratio of the opposite side to the adjacent side, and our opposite side here is 3, all over the adjacent side here is 4. Okay, so inverse of 3 over 4 will now give us 4 divided by 3. Alright, so that's the value for cot alpha. Okay, ladies and gentlemen, that has been our preliminary session as far as trigonometry is concerned. In this particular session, I've established what trigonometry is all about as the study of triangles with respect to their sides and angles. I've also established what trigonometric ratios are as sine, cosine, and of course tan. Of course, they are inverse too. Inverse of sine as cosec theta, inverse of cos as sec theta, and inverse of tan as cot theta. Also in this particular session, I've established what Pythagoras theorem is all about, which says that in a right angle triangle, the square of the hypotenuse side is always equal to the sum of the squares of the other two sides. In our next session, I'm going to establish trigonometric ratios, trigonometric identities. We have 3 of them, and also we establish what complementary angles are. I'll also establish the ratio of special angles, talking about 30 degrees, 0 degrees, 45 degrees, 60 degrees, and of course 90 degrees. Don't go anywhere. We'll see in the next video. Alright.